So the periodic table exercise 2, we did the first 9 questions. Then question 10, the table gives some information about 4 different particles A, B, C, and D. Complete the table. The first row has been done for you. This is related to like completing the number of proton, neutron, and electron and writing the electronic configuration. So you can use a screen annotation to complete. The first one, because the charge on the particle is 0. If the charge on particle is 0, so it should have equal number of proton and electron. So if the protons are 11, the electron should also be 11. The next one, the charge is also neutral. So if it is having 18 electron, again, it should have equal number of protons. So the next one, it has 18 electron and 17 protons. So electrons are more than protons. So it means it should be a negative charge. Like 18 and 17, so one extra electron is there. That's why it should be -1. And the configuration, how the electrons are arranged, we have 18 electrons. So first shell will have 8, second shell 8, and the third shell also 8. Give 2 particles from the table which are isotope. To be an isotope, they should have same number of proton but different number of neutron. So you can see A and B have the same number of proton, but they have different number of neutrons. Element Z is in the same group of a periodic table as A. Z, like there's another element which is Z, and it is in the same same group as A. Which group A belongs to? How we identify A belongs to? As there is 1 electron in the last cell, so it means A belongs to group 1. So A belongs to group 1, and they say that the element Z is in the same group of the periodic table as A, and A is less reactive than Z. For group 1, what happened to reactivity? As we go down the group, the reactivity increases. So means Z should be more reactive. And is less reactive than Z should be less reactive, not more, because this statement, it is less reactive than A. So Z, if Z is less reactive, what should be the position of the Z? The position of the Z should be above A. And what is A here? A is sodium, because there are 11 protons. So 11 proton means sodium. So which element in the periodic table is above sodium? So if A is sodium, which element is above sodium? That is lithium. So we write that Z should be lithium. So how we identify? We identify first that they mention it's a group 1. Why? Because the configuration. And A is actually sodium. And as we go down the group, the reactivity increases, like they become more reactive. But Z is less reactive, so Z is above A. So which element is above sodium in group 1? That is lithium. So lithium is a right answer. C is unreactive. Use information from the table why C is unreactive. What is the reason why C does not react?
Because it has complete valence electrons in the outer shell.
So it has a complete outer shell, you can say, or valence shell is complete. So full outermost shell, that's why. In question 11, rubidium is a group 1 element and it has a similar physical properties and chemical properties to the other group 1 element. Predict how many electrons are there in the outer shell of rubidium. If element belongs to group 1, how many electrons will be there in the last shell? So it will be 1. If element belongs to group 2, how many electrons will be there? 2. If element belongs to group 3, it will have 3 electrons. So group number is actually representing the number of last shell electrons. Predict one physical property which is same as a transition element, such as iron. Like the property, the physical property which is same. So we can mention group 1 are not hard, group 1 are relatively soft, can be cut by knife. So we cannot, even malleability we cannot mention because group 1 colored compound is not, because group 1 does not form colored compound. We want similarity, not the difference. So all metals can conduct electricity. The similarity is that. Why we cannot say malleable? Because group 1 metals are relatively soft. So when we apply the force, they are relatively brittle rather than malleable. Like when we apply the force, we can easily break them, cut them. Instead, yeah, you can mention it has a metallic luster or a shiny surface, that you can mention. Or you can mention both are solid at room temperature. You can mention both can conduct electricity. But you cannot mention malleability. Why? Because malleable means when we apply force, we can hammer into shape. So this group 1 metal, when you apply the force, actually you break the metal rather than you shape. So conduct electricity, or you can mention they have a metallic luster or a shiny surface. Or they are solid at room temperature. Predict two physical properties of rubidium which are different from transition element. Now we want differences. So what could be the two different physical properties?
Low density for rubidium and high density for transition element.
Yeah. So density, low density for rubidium compared to transition element, and low melting point for rubidium compared to other transition elements. Don't mention about the color, the about the colored compound, better mention in chemical one rather than in physical. Physical properties are simply properties. Physical melting point is why physical, like measurable quantities are known as a physical, because there is no new substance form. When we supply the heat energy, what happens? A solid particles, ions move away from each other, but chemical, there's no change. They're like there's no new substance form. Like if you have a water and you supply heat energy, water turn into vapor, like water start to boil. So the composition of the molecule does not change. If it was H2O before, it remain H2O after supplying heat energy. Only thing what happened, the arrangement of the molecule changes. That's why it is a physical property. So melting point, as we supply heat energy, there is no new substance formed. We call that as melting. Like solid turn into liquid or liquid turn into gas, that will be boiling. So there is no new substance formed. That's why these are refers to physical properties. But sometime when we supply heat energy and a substance chemically change, so we don't say it's melting, we call that as a decomposition, thermal decomposition. When the substance completely change. And thermal decomposition is a chemical property, not a physical. So if I say that I have, say calcium is there, which is solid, and I supplied the heat energy and a calcium melted, turned into liquid. So what is this change? Because there is no new substance formed, so I call that as a physical change. And the temperature at which solid turned into liquid is a melting point. But if I have calcium carbonate and I supply the heat energy, as a result, it will form calcium oxide plus carbon dioxide. So this change, when I supply a new substance form, so this change is refers to a chemical change. And this chemical change is known as the thermal decomposition or the decomposition reaction. So if new substance form, it's a chemical change. No new substance form, it's a physical change. In part D, rubidium is added to cold water. Suggest two observations. When alkali metals are added to water, what are the observations?
Vigorous reaction.
So bubbles will be there,
Metal dissolve.
metal dissolve or the solid dissolve. Or these reactions are normally exothermic reactions. So, and even they give you the hint in the question, they use the term cold water. So what will happen? The water will become hot or the temperature of the water will increase. So bubbles will be there, the solid will dissolve and the water will become warm or the temperature rise. What would be the color of the solution if methyl orange? Methyl orange is an indicator because when rubidium react with water, it gives rubidium hydroxide, alkaline solution. So what is the color of methyl orange in alkaline solution? So methyl orange, it is yellow or orange in alkaline and it is red in acidic. So orange, even orange is the first choice, orange is there. Second choice, yellow, both are correct. Write a chemical equation for reaction between rubidium and water. So group 1, when they react, so we have rubidium, Rb, because it's a metal, so atom, react with water, H2O, form rubidium hydroxide. What is the formula of rubidium hydroxide? Rubidium is group 1 and hydroxide is group 7. Sorry, hydroxide is a molecular ion with a charge -1. So rubidium hydroxide will be RbOH. And hydrogen is also given out. Then balancing, we start balancing with oxygen followed by hydrogen. Oxygen is already balanced, then we try to balance hydrogen. So we put 2 here, hydrogen is 4, here on 3. So we put 2, hydrogen is balanced. And then we put 2, so rubidium is also balanced. So 1 mark is for the product, 1 mark is for balancing. So we have group 1 element, we have cesium, lithium, potassium, rubidium, sodium. They are not in order. The order is lithium, sodium, potassium, rubidium, and cesium. Arrange, complete this box. Suggests the most reactive to the least reactive. As we go down, the reactivity decreases. So most reactive will be cesium, then rubidium, then potassium, sodium, and lithium. So cesium, rubidium, potassium, sodium, and least reactive, because as we go down, the reactivity increases. So this should be more reactive. Lithium should be less reactive. Suggest one safety measure that should be used when rubidium is added to water, because there's a vigorous reaction. So what safety precaution we should take? Use eye protection or use goggles. Use wear goggles or using gloves, lab coat. Phosphate ion is PO4 with a charge -3. We have to deduce the formula of rubidium phosphate. So rubidium is Rb and phosphate is PO4. Rubidium is +1 and phosphate is -3. So rubidium phosphate, they have the different valency. We cross multiply 3 with rubidium and 1 with phosphate. So rubidium phosphate will be Rb3PO4. In question 12, part A, 3 halogens in group 7 are chlorine, bromine, and iodine. How does the color change as we go down the group? As we go down, what happened to the color?
Become darker.
It becomes darker. It's not lighter, it should be darker. Why? Because chlorine is yellowish green, bromine is red brown, and iodine is black or purple. So it gets darker. How does the physical state, solid, liquid, or gas, changes as we go down? So what happened to the physical state
From
as
gas
we?
to liquid to solid.
So it changes from gas to liquid to solid. So all three you should mention because one is, this is gas. So you have to mention first it is gas to liquid and then liquid to solid. Predict the color and the physical state of fluorine. Fluorine is light yellow, pale yellow, and the physical state it will be gas. The same question they can ask for acetylene, then it will be color will be black and the physical state will be solid. Describe how you could distinguish between aqueous potassium bromide and aqueous potassium iodide. Like how we can test that we have aqueous potassium bromide and like we have a solution of potassium bromide and we have a solution of potassium iodide. How we can distinguish? So what we can do, like we can either bubble chlorine, the test, if we bubble chlorine or add chlorine, you can say chlorine gas. Because when chlorine react with potassium bromide, it will form bromine. And what is the appearance of bromine in the aqueous solution? It will be orange. And when iodine is there, because when you add chlorine to potassium iodide, so what will happen? It will, because it will form an iodine and iodine is brown or yellow in color. This is one way. Or you can also add bromine to both of them. So when you add bromine to potassium bromide, there is no reaction, no visible change. And here it will form, because bromine displaces iodine, so it will form iodine, so you can mention here. So both ways you can test the solutions. Iodine is black or purple, but iodine is formed in the solution. That is why it is yellow. The test for the water, the chemical test, we can, if we want to test the, like a physical test, it's check the boiling point. If the chemical test, we use copper sulfate or cobalt chloride to test the water. Then 0.05 moles of iodine react with 0.45 moles of chlorine to form 0.03 moles of one product. Complete the equation. So what product? A single product is there, means they combine together. When iodine combined with chlorine, it will form ICl. But that is related to the moles part. So that's why for this is related to moles part, we will not do it right now. In the moles topic, as we will do, the trace of a chlorine can be separated from bromine by vapor by diffusion. Which gas will diffuse faster? Chlorine, because it has a lower atomic mass, so it will diffuse faster. Like we have a chlorine with bromine, both are vapor. So if you want to say separate them, we can use the diffusion, and chlorine is lighter, so that's why it will diffuse or move faster. Question 13, fluorine and acetylene are halogens. What is the state of fluorine? What is the state of astatine solid? Two similarities in the chemical properties, like the way they react with the other substance. So in chemical properties, you can mention both. When they react, they tend to lose one electron because group 7 react to by losing one electron. That is one thing. Second, you can also mention like they react with metal to form salt. So similarity in chemical properties, they both will react by loss of or losing one electron as belongs to group 7. And the second thing, they both can react with metal to form the salt. React with hydrogen to form acid, that's also correct. Because like hydrogen fluoride, hydrogen bromide, hydrogen chloride, so that will form an acidic solution. So the one is they react by losing, by gaining, sorry, the first one by mistake I wrote losing electron. It's a non-metal, so it should be gaining electron. So they react by gaining one electron, not losing, because these are non-metals. Non-metal tend to gain electron. So they react by gaining one electron. That is one thing. The second is they react with hydrogen to form acidic solution like hydrogen chloride, hydrogen bromide, hydrogen iodide. So they all form acidic solution and they can also react with metal to form salt. So react with metal to give the salt. So you can mention both have the valency of one. You can mention both can react with other metal to form halides. You can also mention react with other non-metal to form covalent compound, react with metal to form ionic compound, or these are non-metal, so they tend to form acidic oxides. In question 14, we have to select a period for each of the following. We have to select an element from period 4, potassium to krypton. This is period 4, potassium to krypton, this region. So you have to select element from this region only. The first one, it is a brown liquid at room temperature. So when we check the periodic table, you'll find bromine is there. So that is bromine. It forms a compound with hydrogen having a formula of XH4, means like share 4. So which element can share 4? You will check when you check the period 4. We have to select period 4. We can carbon is period 2. We cannot write carbon. That will be wrong because we have to select the element from period 4 only. So which element? So it is germanium is there. So germanium, we have to select germanium as it belongs to period 4. The group 4 element belongs to period. A metal that reacts violently with a cold water. So it should be group 1, period 4, group 1. So that should be potassium. You cannot write cesium here. Why you cannot write cesium? Because you have to select the element from period 4. Only you're restricted to this period. You cannot select any other element, means element other than this period. Cesium is not in period 4, it's period 6. So you have to select element from period 4 only. That's why potassium is the right answer. It has a complete outer shell energy level. So which period 4, which group 8? So that is krypton. Yeah, so that was krypton. Oxidation state 2 and 3 means variable oxidation number. So you can select any element in this region because these are transition element of the period 4. Zinc and scandium are not categorized as transition. You will learn that in A levels, not in O levels. So you can select any element from this. Normally iron is having +2 and +3. So iron is the most accurate one, but you can select any other element. It can form an ion with type X-1, means it gain 1 electron, means group 7. So which is group 7? So again, it will be bromine. Yeah, so again, it will be bromine here. And then one of its oxide is a catalyst for contact process. We use its oxide for a contact process. We use oxide. So which one is this? That is vanadium. Vanadium oxide is used. Vanadium pentoxide is used as a catalyst for a contact process. In part E, it has the oxidation state of +2 and +3, means it has a variable oxidation number, means you have to select a transition element. So if you want to have a variable oxidation state or variable valency, it means it's a transition element. So you will use the periodic table and identify period 4, what are the transition elements in period 4. So this region we have transition element. So normally, like you can select any of them, but commonly iron is +2 and +3. That's why we select iron. If you select other than iron, that is also correct. Like you can select manganese, chromium. Common one is iron, which is having +2 and +3. In question 15, group 1 metal shows the trend in both their physical properties and chemical properties. How do the melting point vary down the group for group 1? As we go down, what happened to the melting point from lithium to cesium? It's get lower or it decreases? Which element in the group has the highest density? As we go down, the density increases. So the correct answer is cesium. Because group 1 or all the groups, as we go down, the density increases. Then group 1 metal react with cold water. We have to complete the equation. These metals usually have low densities, but their density increase as we go down the group. Usually they have low densities, but density increase as we go down. So lithium in the group will have low density and cesium in the group will have high density. Then this will be the equation for forming lithium hydroxide and hydrogen. Then lithium react with nitrogen to form an ionic compound. State the formula of lithium. Lithium is a group 1, so it should be +1. Group 1 +1. Because these are metal, metal tend to lose electron, so it will be +1. Deduce the formula for nitride. Nitrogen is the nitrogen is group 5. Group 5 is -3. 3 minus or -3. Then in all solid ionic compound, ions are held together in a lattice. Explain the term lattice. Lattice is a regular arrangement. Sorry. So what is a lattice? Lattice is basically a regular arrangement of the ions, or you in ionic compound, when you define the ionic lattice, regular arrangement of oppositely charged ions. And if it's a metallic, then you will say regular arrangement or lattice of a positive ion or cations. Why is the ratio between lithium ion to nitride ion? What is the ratio? And so it will be 3:1. Why 3:1? Like one lithium is +1 and nitrogen is -3. So this cross multiplies, so it will be Li3n. So we need 3 lithium and we need 1 nitride. And give a reason why. To balance the charge, to balance the charges, or you can also mention to balance the charge, we need 3 lithium and we need 1 nitrogen. Like 3 lithium will lose 1 lithium lose 1, 3 lithium will lose 3. And these are taken by the nitrogen, so the charge will be balanced. In question 16, choose an element which fit each of the following description. It is a yellow solid which burns to form acidic oxide. This is about sulfur, and sulfur is not part now in the latest, after the changes. Sulfur is not the part, but the correct answer for this one is sulfur. So you will not learn anything about sulfur. The element which is black solid when heated form a purple vapor. So that is iodine. Iodine is black solid. When you supply heat energy, it will turn into vapor. Not astatine. Most of its soluble salts are blue. Like when this substance dissolve, like make it salt solution and you dissolve, it will be blue. So the copper is correct. It has a basic oxide, which is used for treatment of acidic soil. Again, this part is removed from the syllabus. Why not astatine? Because astatine, the iodine form a brown or a purple vapor. Astatine will form the same color, like example, a black color vapor, not purple. Iodine is purple vapor. So calcium is there. Calcium oxide is used for the treatment of the acidic soil. But we have to just mention the name of element, not the compound. So you don't have to mention calcium oxide. You just have to mention calcium. And it is unreactive gas, which is used to fill balloon. That is helium. So this part, so these three only you have to know. These two parts are omitted from the syllabus. Like you will not learn about treatment of the acidic soil as well as the appearance of a sulfur. Question 17, 3 halogens are there of the 3 halogens of group 7 are there: chlorine, bromine, and iodine. How does the color change? It's a similar question. It gets darker. How do the melting point and the boiling point? As we go down, it decreases. No, it's a group 7. Group 7, melting and boiling point increases as we put out. For group 1, it decreases, but this is about group 7. And then predict the color and the physical state. It's a solid astatine. And what is the color? It's black. Then like about 2 more questions are there that you will solve these questions later, like when I give you the homework.